Okay, radians is often measured in pi, and pi is equivalent to 180 degrees. So when we're dealing with radians, there's normally a pi, or they can use decimals, but you just need to know that pi is equivalent to 180 degrees. Pi over 2 is 180 over 2, which is 90 degrees, and 3 pi over 4 is 3 times 180 over 4, which is 135 degrees. So if you're converting from radians into degrees, just replace your pi with 180 degrees. Okay. If you're given the degrees and you're trying to get your answer back into radian format, just stick a pi on the end and divide it by 180 and simplify it down. So here we get pi over 4. You need to know your exact values. So we learn two triangles. Here's your first one. You can see there's a 60 and a 30 degrees in there with a 1, 2 and a root 3 round the triangle. So from SOHCAHTOA, you should know that sine 30 would be opposite over hypotenuse, which would be 1 over 2, which is a half. Cos 30 would be adjacent over hypotenuse, so root 3 over 2. And tan 30 would be opposite over adjacent, so 1 over root 3. You can do the same for sine 60. Sine 60 would be opposite over hypotenuse, so root 3 over 2, and so on. And then this is our other triangle we can get our exact values from. So sine 45 would be opposite over hypotenuse, so 1 over root 2. Cos would be the same because the 1 is the opposite and the adjacent. And tan 45 would be 1 over 1, which is just 1. But you've got your exact values table on your notes, so you can just memorize them all, or you can just learn both of these triangles and you can get all your answers from them. Another way you can figure out your angles, exact value angles, would be to look at the sine curve and cosine curves that you should already know from last year. So if I said to you sine 90, you should look at that graph and know that the answer is going to be 1. Or if I said to you sine 270 degrees, you should know that the answer would be -1. Now, the next thing you need to know is how to do equations. Okay, so here's one here. Again, we did this in Mat 5. I've rearranged the sine 3x to give us 1 over 2, a half. And from your exact values table, you should know that's 30 degrees. Because it's positive, we've ticked the first two quadrants. The problem here is it's a 3x instead of an x, so what we'll have to do is divide by 3. Now, where have I got all those extra answers from? Because we've only ticked two quadrants. If you can remember that sine and cosine repeat themselves every 360 degrees and tans every 180 degrees, then we're allowed to add 360 degrees on to these angles as often as we like, but we don't want our final answers to be out with the range. So the range here was the x had to be between 0 and 360 degrees. So I've added on, if it's a 3x, I tend to add on the 360 another 2 times to both angles. And if it was a 2x, I would just add it on 1 more time, and that should be enough. Now to get from 3x to x, we've just divided by 3, and that's our final answers. So if you go back to the 3x equals 30 degrees and 150 degrees, normally that's where you would have stopped last year, but now we do 360 plus 30, and that gives us 390 degrees. 360 plus 150, that gives us 510 degrees. And then I've just added 360 onto 390 and onto the 510 to get those last two. And when you divide by 3, we end up with 6 answers. If your range was between 0 and 2 pi, you can work in degrees, but make sure you put your final answer back into radians at the end. Okay, hopefully that helps.